All right, guys, here's some notes on what we did in class today. We have parallel and perpendicular lines. So if two lines are parallel, let's get my text box out for this. Whoa. Parallel, then they are going to have, they have the same slope, okay? So we're going to see when we start looking at lines that are parallel to one another, two lines that are parallel are going to have the same slope. Vertical lines are always going to be parallel to other vertical lines, as well as horizontal lines are always going to be parallel to other horizontal lines. Now we've graphed multiple horizontal and vertical lines before, and it should make sense because vertical lines, if we have a line going straight up and another line going straight up, obviously those look parallel, same as horizontal and horizontal. All right, now those aren't perfectly drawn, but we should be able to see that, they're going at the exact same rate, and the definition of parallel is that it's something that's never going to touch the other line, right? Like train tracks, they go on forever without intersecting, ideally. If two lines are perpendicular, though, so let's go put in perpendicular. If two lines are perpendicular, they have not the same slope, but they're going to actually have the opposite and reciprocal. Okay, so they're going to have the opposite and reciprocal slope. So the numbers are going to be very similar. We just are going to be switching a few things on it, and we'll show you what that means. And so vertical lines are always going to be perpendicular. They're going to be perpendicular to horizontal lines. And we can think of perpendicular lines as like an intersection at like a stop sign, right? So if we have a street going this way and a street going this way, this would be like our stop sign in the middle, our four-way stop. So vertical lines are going to be perpendicular to horizontal lines. So opposite and reciprocal. So the opposite, we've talked about opposite before. If it was positive, the opposite of a positive. So the opposite, the sign changes, okay? For opposite means the sign changes. So the sign changes, positive becomes negative, or negative becomes positive. All right. So that's all that it means by the opposite. Now reciprocal, you guys might have had reciprocal before. All we're doing is taking the fraction and we're flipping it. Okay, so the bottom number becomes the top number and the top number becomes the bottom number. So reciprocal means to flip the fraction. Okay, so in order to find the opposite and reciprocal of a slope, we need to change it from, like in this example, this is 4/3. Well, we changed it to a negative. That's the first thing. And we also flipped it to 3/4. So when we have a slope that looks like this and looks like this, they are going to make perpendicular lines. Always, 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 they're going to be perpendicular. Two lines that have the same slope are always, always, always going to be parallel. So what we're going to basically do down here, guys, is we're going to determine if the given equation of the line is parallel, perpendicular, or neither. And we're just going to look at the slope. So let's highlight these right now. We're going to look at just the slope here. So we see 2/3 and 2/3. These are the exact same slope, so we know that they are going to be parallel lines. Easy as that. Now this is a +3 and this is a -3. So a +3 and -3, those are opposite. But what is the reciprocal of 3? Technically it's 3/1 would be 1/3. So it would be 1/3. So So although this is the opposite of 3, it's not the reciprocal. So this would be a neither because it has to have both. So now we have 5 over 2, and then we have 2 over 5. Well, that's good, right? Because it's flipped. We flipped it. We took the reciprocal of it, and it's the opposite. This is positive. This is negative. So these are going to be perpendicular. Oops. And then the last one, ICULAR. I put an S in there. Okay. And the last one, where is our slope? Okay, our slope is this 2 and this 2. They have the exact same slope. Whenever two lines have the exact same slope, we're talking about parallel lines. There we go. Awesome. So that's all we had to do, guys. So this next part, though, is going to be a little different, and this is going to take a little extra work. But we want to write the equation of a line, and we want to put it into point slope form that is parallel to the graph of each given. Okay, so we know that number 5, this is going to create some type of line. Okay, so we have a line that number 5 is going to create. We want to create another line that is parallel to that, just like that. Okay, the kicker is we want to make sure it goes through. We want to make sure it goes through this point. All right, so how do we do that? Well, we know point slope form. We know point slope form is y minus y equals mx minus x, right? So we already know that. We know that on a parallel line, that our slope has to be the exact same. So I already know that we are going to go y and then equals, and my slope has to be the same, so I'm going to keep it as 2 because my slope was 2 up here. If it's asking me to create a parallel line, the slope has to be the same, and we already know that the y and the x are going to stay the same. So now we just need to fill in the missing points, and the missing point is right here, 6, 4. Now the only thing is when we put them, they're both positive numbers. When we put them into our equation, they have to be the opposite. So this could be a minus 4. Because the 4 is our y, and this would be a minus 6. Now, this line that we just created and this line would be parallel when we graph those. Okay, so that's all we're doing. We're taking the point and we're taking the slope. We do know the slope, and we are going to put those into our formula. Okay, now that's point slope. This one's a little different. This one is a y equals mx plus b. Okay, so we want a line that is parallel to this, but also goes through this. So we actually have to do a little bit of math here. What do I know is going to stay the same? Well, I know I'm going to have y equals 1/2 x plus b. Okay, I know it's going to look like that because I want to have the exact same slope. Now, we know the b is going to change because if the b was 4, they're going to be the exact same line. We don't want 2 of the exact same lines. We just want 2 lines that are parallel. So we've had to find a new b before. We did this a few sections ago. What we're going to do is we're going to take our point and we're going to plug it into our equation. So we're going to use the x and use the y to solve for a new b. So we're going to take 7, 1/2, 4, 1/2, 4, -2. And we're going to find our new b. Okay. So now it's just a mathematical equation. You're going to take that 0.5 and you're going to times it by -2. All right, that's going to be the first thing you're going to do. And if you need to use a calculator, make sure you guys do that. And then you're going to just bring it to the other side. So I'm going to take 7 equals 1/2 times -2 is -1. What's half of -2? It's -1 plus b. All right, and then what we need to do then is bring the 1 to the other side by adding it to the other side. And b equals 8. At this point, we have a b. We have a new b. We want to use the same slope. So we are just going to, we have all the information we need to write our equation. We are going to have, let me circle this one so So that's our answer over here. And our answer over here is going to be y equals the exact same slope. So we're going to have the same slope as up here, 1/2 x plus 8. Now remember, parallel lines have to have the same slope. And in this situation, is this slope and this slope the same? Yes. It doesn't matter about any other number, but we have to, how do we find the b? Well, we use the points that's given. So you guys got 2 more examples of those, okay? Number 8 is going to be just like number 5, and number 6 and number 7 are going to be very similar. So you guys are going to use your time to finish those 2 out. We'll give you time in class, but I'm not going to do those right now. Then the other thing we're going to talk about is perpendicular lines. Now, this one we have to do a little more thinking because the slope's not always the same. We want it to be the opposite and the reciprocal. We want to flip it, okay? So one of the first things we always want to look at is what is our new slope going to be? So this is a +2. So what is the opposite reciprocal of a +2? Well, I know it's going to be at least a -2, right? And what is the opposite? This is technically 2/1. So in order to flip 2/1, our new slope is going to be 1/-2. Okay. Or the negative can go with the top number. Right there. So that's our new slope. So now we're going to go y. I'm going to use my xy from right here. So my y is a 3. So y opposite, right? We always take the opposite of that. So it's a -3. So we want, or this is a +3. So we want it as a -3. My bad. Opposite. Equals my new slope, which is -1/2. And then x -3. My bad again. This are y or x -0. Sorry. There we go. That's all we had to do. So point slope is a lot easier, guys, because there's less work. Right. So just like this is the opposite reciprocal of this slope. And up here, we wanted the exact same slope. Same slope makes parallel lines. Opposite reciprocal slopes make perpendicular lines, okay? So that's how we do it with a point slope. And now let's try one with, I'll do number 11. Let's try one that is in our y equals mx plus b. Okay, so the first thing I want to do is identify my slope. My slope is -4. And I'm going to put it over 1 just, I think that's easier to see when it flips. So what is my new slope going to be? Well, my new slope is going to be positive, and I'm going to flip both signs. So it's going to be 1/4. So that's going to be the new slope that I'm going to use. Okay, just like I did it in my last one. Use this slope. Oops. Use this as my new slope, just as this was my new slope over here. Okay. So you don't have to write that out, guys. I think it's sometimes nice to write out your slope so you can see what you're working with. Now I got to put in the information I know. Remember, this is your x, and this is your y. So I'm going to plug those 2 pieces of information and my slope to find a new b, just as I did up here. I want to find a new b, y equals mx plus b. Okay, so my y is 2 equals, now I have a new slope, right, 1/4 times 1 plus b. All right. And then you're going to go ahead and solve this problem just like we were doing before. So 1/4, and obviously whenever you take any number times 1, it stays the same, right? So basically what we want to do is subtract 1/4 from both sides. Okay. I'm kind of skipping a step there just because I know that 1/4 times 1 is going to be 1/4. All right, so we're going to subtract the 1/4 from both sides. And we can go ahead and get a decimal here. That's fine. If you do 2 minus 1/4 on your calculator, let's see, 1/4. Yeah, we'll give you a decimal right away. Think of it as quarters, right? So that's like 0.25. So 2 minus 0.25 is 0.175 equals B. And that's our line. So now I'm going to take my y equals my new m. My new m is 1/4. It's the opposite reciprocal of my original number, and then plus 1.75. Now, if you were to graph these two lines, they would intersect perfectly, perpendicularly, all right? Would say meet at a 90-degree angle. We'll learn about that later, but it's perpendicular, all right? And again, guys, we should have done this in class, so this should be just a little bit of a review. But yeah, here's the 4 problems that we talked about in class, our new parallel and perpendicular lines.